Hello everyone. Today we will be discussing about peppermint or peppermint oil and its antibacterial and antioxidant effects. The peppermint is a combination of Menthe piperita and Mentha aquatic. It was first grown and used by the Egyptians during the 13th century, then grown by more countries in Europe, North America, and North Africa. Now it's very popular that it's grown in all regions of the world. The essential oil, which is the most important part because of its medicinal effects, are extracted from different parts of the plant, and these are the dried leaves. Flowering part and stems, the peppermint produces about 0.1% and 1% of oil, which is composed of menthone, mesophyrin, and methyl acetate. Menthol can be used for toothpaste, tooth powder, chewing tobacco, food, mouth freshener, cough drops, gums and candies. The fresh and dried leaves can be used for breath fresheners or mouthwash, drinks, toothpaste, chewing gum, tea, candies and ice cream. Medicinally, peppermint is medicinally used for aromatic, antiseptic, and antispasmodic. It is also used for treating cancers, headaches, colds, cramps, indigestion, nausea, sore throat, and toothaches, and it's found to be an effective antifungal and antiviral agent. With the uses and effects that I have mentioned about peppermint, I will discuss its antibacterial activity and its effects against gram-positive and gram-negative bacteria by agar well diffusion method. Now let's talk about the materials and methods. The materials used for this experiment were Mueller-Hinton agar, or MHA, which is used to screen the bacterial activity, and the other is analytic Jena spectrophotometer that measured the reaction absorbance. The methods used were first the distillation of oil, wherein the dried leaves, peppermint leaves were chopped and then heated at 60 to 80 degrees Celsius until no more oil was extracted. Then the oil was filtered and stored in dark bottles at 4 degrees for testing and analysis. The second part was the extraction of Mentha piperita leaves. A kilo of dried chopped leaves were placed into a flask and then subjected into a hot extraction by refluxing of 2-liter petroleum for either for 3 hours, and then let it cool and filtered. The other plant material were refluxed with chloroform, ethyl acetate, ethanol, distilled water for 3 hours, and then allowed it to cool down, then filtered. For the determination of antibacterial activity, they used 2 gram-positive and 2 gram-negative bacteria. The gram-positive were Staphylococcus aureus and Streptococcus pyogenes, while the gram-negative bacteria were used for E. coli and Klebsiella pneumoniae. Then they were prepared the standard inoculums, where the microorganisms were inoculated into the Mueller-Hinton broth with 5% sheep blood and incubated for 12 to 15 hours at 37 degrees Celsius. The incubated suspension was diluted into the MHB to match the McFarland turbidity standard, which is equal to 3.0 times 10 to the 8 CFU per mil, or 0.5 McFarland standards.
The protocols used in this study were based on guidelines of CLSI, formerly known as NCCLS, with a slight modification. Fresh cultures of the indicator stains of bacteria were added onto Mueller-Hinton agar MHA containing 5% sheep blood, and the MHA was mixed and poured over Petri plates with dried correspondent agar medium on the surface of sterile tubes, and after solidification of the MHA, the tubes were removed and the obtained vials were filled with the pipettria extract and oil. After that, in order to accelerate diffusion of the essential oil into agar, plates were incubated at 4 centigrade for 1 hour and were incubated at 37 centigrade. And after 24 to 48 hours of incubation, the antibacterial activity was evaluated by measuring the width of the zone of inhibition of growth against the incubator organism in comparison to a control of reference standards. And all these tests were performed in triplicate. And to establish the nature of inhibitory activity of the oil, samples were taken from the clear zone with a loop and surface plated onto a pre-sheet agar and incubated under optimal conditions for up to 48 hours. And minimum inhibitory concentration and minimum bacterial concentration were determined by the broth, the older micro dilution methods in molar Hinton broth, supplemented with 5% sheep blood for bacteria stains. And MIC was defined as the lowest concentration of M. piperita essential oil that allows no more than 20% growth of the bacteria, which is seen as the decreased number of the colonies after removing the loop of each dilution on MHA and incubation at 37 centigrade for 18 hours. And MBC was defined as the lowest concentration of the peppermint oil that allows no growth of microorganisms, and gentamicin served as a positive control while PET. Ether, chloroform, ethyl acetate, ethanol, and water were included in every permanent as negative control. With the application of agar medium as per manufacturer's instructions, the test was performed. A solution of 10 grams per milliliter of gentamicin in the form of a standard antibiotic disc was used in order to provide a positive control, while PET, ether, chloroform, ethyl acetate, and ethanol and water were included in every experiment as a negative control for the sensitivity of the indicator organism. All determination were carried out in a triplicate. The antibacterial activity of the M. piperita oil and different extracts was assessed using the agar well diffusion method by measuring the diameter of growth inhibition zone at different concentrations. The clear zone around the disc were measured in millimeters, and the antibacterial activity of oil and plant extracts were indicated by clear zones of growth inhibition. SOROS was found to be the most sensitive, followed by cyphogens and Klebsiella, which were found to be more sensitive to essential oil when compared to E. coli. And so it is effective against gram-positive and gram-negative bacteria, and more effective against gram-positive organisms when compared to gram-negative. And the Petri The peppermint oil exhibited a greater zone of inhibition against SROs, physogens, and cough pneumonia than the positive control gentamicin, as shown in Table 3 and Figure 3. And however, the peppermint showed a lesser zone of inhibition against E. coli than gentamicin. The antibacterial results for different extracts indicate that the PET-ethyl, chloroform, and ethyl acetate extracts were found more effective than compared to ethanol extracts. And among the organism test, PET-ethyl and ethyl acetate extracts were more effective against S. aureus and cough pneumonia when compared to S. physogens and E. coli. And a similar trend is observed in case of ethyl acetate. The antibacterial result for different extracts indicate that the PET-ethyl, chloroform, and ethyl acetate extracts were found more effective compared to ethanol. And among the organism tests, PET-ethyl and ethyl acetate extracts were more effective against S. aureus and cough pneumonia when compared to S. physogens and E. coli. And a similar trend is observed in case of ethyl acetate, and it was established that the fraction containing the high concentration of oil inhibited the growth of microorganisms. Results were compared with antibiotic gentamicin. It's used to show less strong inhibition for gram-negative bacteria and pronounced inhibition for gram-positive bacteria. And antimicrobial and antioxidant properties of essential oil are of great interest in food, cosmetic, and pharmacy industries since their possible use as natural additives emerged from the tendency to repair some problem of disease. Furthermore, the MBC and MIC ratio is clearly higher than 1, indicating a bacteriostatic effect of the essential oil, and the underlying antimicrobial and antioxidant mechanism of the essential oil, as well as their active components, need to be further studied and clarified. And additional studies and clinical trials would be needed to justify and further evaluate the potential of this oil as an antibacterial agent in topical or oral application.